Hey everybody, it's Marm. This video is to help you with this packet. So hopefully you've already watched the video. If you haven't, go back and do it right now. But some people are wanting some extra help, so you might want to pause it. Once I've explained some things, do some yourself, and then play it back and check your answers. So I want to notice that this HCO3 minus loses its H. So I draw the arrow showing the movement of the H plus. This NH3 gained the H. It now becomes NH4. So I know this is my acid because it's losing it, and this is the base because it's gaining the H plus. And now if I look on this side, the H moves from here to here. So this is my acid and this is my base. So I'll do just a couple more with you. Here the H2O becomes H3O, so I know my H moves this way. The HCl becomes just Cl. So this is my acid and this is my base. And if I go backwards, this is going to be gaining it, so it's my base, and this loses it, so it's my acid. So go through and do the rest of those for practice. And then over here, this is what I really want to focus in on this video to help you out with. So every time you have a neutralization, you have an acid plus a base, and you're making water and a salt. So the H and the OH come together, that's my water, and my Na and my Cl come together. So I got to put the charges on everybody. This is a plus one, this is a minus one, and that's how I get NaCl. Reactant 1 was hydrochloric acid, which is an acid. So how did I get that? First of all, it starts with an H, gives it away as an acid. I go to table K, it's the first one listed. Since it's a binary acid, binary acids only have an H and a non-metal, and they always start off with the name hydro. So if it was HBr, it'd be hydrobromic acid. If it was HF, it'd be hydrofluoric acid. All right, reactant 2 is sodium, and then I go to table E, and OH is hydroxide, and I don't change those names, so sodium hydroxide, there's my base. And it's a base. HOH is water, so I'm just going to write water across here because you don't really have to write out its name. NaCl, sodium chloride. And that is an ionic compound. All right, next one. So the formula is always an acid plus a base makes an ionic compound or an ionic salt and water. So what type of reaction? It's double replacement. And refresher for rules, write the atoms with the charges they will take on when bonding. This represents how many electrons they would lose if it becomes a positive ion, or how many electrons they would gain if it becomes a negative ion. Crisscross the charges. Don't forget to do this or you will not get the correct products. The final formulas do not have charges. If you cross a number down to a polyatomic ion, make sure you use parentheses. When naming, first determine what you're working with. Is it an acid, a base, or an ionic compound? If it's an acid, is it binary or ternary? If it contains a polyatomic ion, you got to use table E. If it's a transition metal, show the oxidation state with Roman numerals. All right. Practice writing. Include both names and write out and balance the formula. So hydrofluoric acid. So hydrofluoric tells me I'm only going to have an H and one other element. So the other element is F. H is a plus one, F is a minus one. So hydrofluoric acid is HF. That reacts with magnesium hydroxide. All right, Mg, I look it up, it's a plus 2. OH, I look it up, it's a minus 1. I crisscross and I get MgOH2 because I got to crisscross that 2 down. To form All right, so now I'm going to put the H and the OH together. So that's going to give me H2O. So water is one of my products. And then I want to put the Mg and the F together. Mg is a +2, F is a -1, so MgF2. And the name of that would be magnesium fluoride. And then I want to balance it. So 2 F's means I got to put a 2 here to have 2 F's, and that gives me 1, 2, 3, 4 H's. So I put a 2 there, and now I'm balanced. All right, let's move on to the next one. Blank reacts with blank to form water and chromium phosphate. So now they're giving me the products first. So H2O is one of them. So first of all, I know I'm going to have a base. I'm going to have something with an OH. And I know I'm going to have an acid. So I know I'm going to have something that starts with at least one H. All right, chromium 3. Cr with a +3 charge. Phosphate. PO4, and that's a -3. So the other product was Cr, PO4. Okay, the Cr is going to go over here with the OHs. This was a +3, so it means I got to crisscross and give the 3 there. And then PO4, that was a 3. Oops, not a B, a P. All right, PO4. And this was a -3, so that means I need H3PO4. All right, to name it, I go to table K. H3PO4 is phosphoric acid. And CrO3 would be chromium 3 hydroxide. All right, and balancing it. 1 Cr, 1 Cr, 1 PO4, 1 PO4. I didn't even need the parentheses on this. I should probably rewrite it without the parentheses. I just wanted to keep it separate. So H3PO4. Okay, 3 OHs. So that means I'm going to need a 3 there. That'll give me 6 H's, and 3 O's. All right, I'm balanced. All right, next one, HClO2. So HClO2 is definitely my acid, and VOH4 is my base. So I'm going to put the H and the OH together. So one of my products is water. And then I want to put the V and the ClO2 together. So V is a 4. The reason I know that, it crisscrossed a 4 down. So this was a 4 and this was a -1. All right, ClO2. You could look it up on table E, or you could say, you know what, it's got to be a -1 because H is a +1 and there's no parentheses and no crisscrossing down. So this must have been just a +1, -1. So my V is a +4. My ClO2 is a -1. So my other product is V, ClO2 in parentheses, 4 of them. And then to balance it. So let me just erase this so I have a little more space and grab a different color. 1V, 1V. 4 ClO2. So I got to put a 4 in front of that. That gives me, let's see, 4 O's. I'm going to need a 4 in front of this. There we go, balanced. When you neutralize an acid with a base, you expect the pH of the final solution to be neutral. So you expect it to be around 7. What acid or basic conditions may lead to the pH being different from expected? Well, if you have one extreme. So let's say you have a really strong acid and a weak base, it's still probably going to be under 7. It's not going to completely go to 7. All right, H2CrO4, is it an acid or a base? It's an acid. How do I know? Starts with an H. That's usually the biggest giveaway. Name it. So I go over to table K, and it's not on there. So when it's not on there, I have to go to table E, and I look at how other ones that were named on table K are like it. So this is chrome 8, Any of the ones that were 8 got changed to X. So chromic acid. If placed in an aqueous solution, what will be the most common ion in the solution? H plus. And as it's added to water, the ion H3O plus, which is called hydronium. Again, I get this name right from table E, hydronium forms. Would it be able to conduct electricity? Yes. What is necessary? You have to have mobile, which means they're moving around, and this is a solution, so they're definitely moving around, charged particles. Well, I'm going to have a lot of H pluses, so acids always are able to conduct electricity because those H pluses are moving around. Would it react with a metal? Yes, acids do react with metals, and when they do, the metal, so let's just show, like if I reacted this with Mg, the Mg would end up with this, so your other product would be H2, hydrogen gas. This solution turns yellow in bromothymol blue and in methyl orange. What's the pH range according to this data? Okay, so I'm going to go down here and I'm going to go look up table M. And on table M, if it is yellow in bromothymol blue, if it's yellow, it's 7.6 or higher. And it's yellow in methyl orange. Oh, I'm sorry. I just read this wrong. Ah, I take it back. Erase, 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 erase. Okay, yellow in bromothymol blue. I was looking at blue. Yellow is less than 6. And methyl orange, when that turns yellow, it's greater than 4.4. So I just narrowed down my range. I know my range, it has to be between a 4.4 and a 6.0. That is my range based on those colors. All right, choose a substance that when mixed with it would increase its pH. All right, so to increase the pH, I have to add a base. And I'm just going to go to table L, and the first one listed is NaOH, and the name of it is given to me, sodium hydroxide. All right, so what I encourage you to do next, I know the worksheet is over, but I encourage you to take any of the acids from table K. So like H2CO3. Add it to one of the bases, NaOH. And you go through and figure out what the products will be. So I'm going to just stop for a second. You're going to pause it, and then you're going to replay it, and I will explain. All right, so the H and the OH come together. That makes water. And then I want my Na and my CO3 to go together. This is a plus one, this is a minus one. This 2 came from up here, so this is the minus 2 and this is the plus 1. So when I put Na, which is a plus 1, with CO3, that's a minus 2, my other product is Na2CO3. So you can go through that, challenge yourself, and make sure that you can write the neutralization reactions for these. And then go ahead and balance it. All right, thanks guys.